about is something called tidy data. And as its name sort of suggests, tidy means clean. So whenever we're working with really any type of data manipulation, but especially when we're working with ggplot, it's really good that your data follows this sort of well-organized manner, because ggplot is actually quite smart and it can recognize the different variables that you have in your tidy data data set very easily. So I'm going to give you an example of what this tidy data format might look like. So here I just have some general information about some different samples. So if our data set were to follow tidy data structure, each variable would be represented as a column. Right here we have state being a variable, and we also have age. Each observation would be represented as a row. So if these were samples, each and every one of these samples is likewise corresponding to a row. And then in each and every cell, we have the actual values for this data. So to start off our lesson today, I have sort of a little tiny activity data set, and it's about a farmer that's recording information about some of the cattle on his farm. This data is actually not in the tidy data set format. You might have noticed, you might not have noticed, but I'm going to give you all about 5 minutes. You can do this on a blank sheet of paper, or you can do this on your computer. If you were to try to organize this data as tidy data, what might it look like? And whenever you are done, feel free to type done in the chat. And if you need help, again, you can always message Sahar, Kavanch, or myself. So it looks like some of you are getting done organizing your data. I'll give you all about 1 more minute and then I'll talk about what the answer might look like. Okay, so whenever you're looking at potential variables in this set, the male versus female might have been a little bit confusing, and this one was a little bit of a challenge. So, oops, let me skip on the next slide. So the way I would arrange this in tidy data would actually be to collapse those originally two rows into a single gender column for our variable gender. It doesn't really matter which order you listed your variables, but making sure that the variables are listed as columns like weight, gender, breed, sample names, and that each of your observations, which in this case were our samples, are listed as your rows. So if you all have any further questions about this, you can put it in the chat, you can message one of the helpers, or we can talk about this at the end. So what I'm going to do now is I'm going to switch over to our console. If I can get out of this, I'm going to stop sharing really briefly. Okay, here we go. So we're going to work with the gapminder data, which you all probably worked with last week. So if anyone needs help downloading that data, please let me know and I can put the link in the chat. But for now, go ahead and open up your R console and I'll start sharing my screen once more. And another thing I want to mention, I'm going to be focusing my lesson on ggplot. If there's extra time at the end, though, I do have the answers to the homework that Davis assigned you last week. So that's something I might save for the end if we have time. If not, though, I can be sure to have those answers emailed to you. So just to go over some basics, basic form in R, it's always great to open up a script and to work with your script. That way everything's saved instead of working directly with your console. So the first thing you want to do is set your working directory, like I said, to wherever the gapminder data is. So I'm going to get WD with parentheses is, and of course I'm going to click Command or Control Return depending on if you have a MacBook or a PC. And it outputs with my directory, and this is exactly where my data is stored. If you haven't had a chance already, you want to install the ggplot2 packages, which you can do install dot packages with parentheses, and then you want to put quotation marks and ggplot2. If you already have this package installed like I do, and once you're done installing this package, you can write library in quotation marks ggplot2. So please in the chat box write done if you have your ggplot2 installed and you have it ready to work with by doing library ggplot2, so I don't go too fast for you all. Let's see, chat. So while some of you are getting this downloaded, I'm going to go over just a little bit about the basics of ggplot. So ggplot is an excellent package in order to make, like I said in the beginning, publication quality figures. And it sort of revolves around three primary things. The first is the data set that you're actually going to have it make a figure depicting. The second is a mapping aesthetic, which you'll see later is one of the requirements for the ggplot function. This basically tells ggplot how you want your data to be mapped aesthetically. So if you want text to be certain colors, what data you want on your X or your Y axis. And finally, it involves different layers. So if any of you have worked with Photoshop or Inkscape or anything that involves adding layers to figures, that's exactly how ggplot works. And we'll get into that in just a little bit. So I'm going to go ahead and assume everyone has it downloaded and ready to run. If not, please contact one of the helpers. So the first thing I want to do is define the data set that we're going to work with today. So I'm going to store the gapminder CSV file, which you all have probably been working with already as gapminder. And I'm going to read.csv, since this is the file type, in quotation marks. I'm going to write gapminder data_data.csv and return. And I always do this with my data. I always like to do the head of my data just so I get a general feel for what the data structure looks like. And as you will probably, and it's probably similar to what I'm assuming the other data sets that you all have worked with. You've probably already been working with tidy data where each of these variables is stored as columns. You have values and cells, which we can't see because we're not in an Excel program, but you could imagine, and then our observations as rows. So now I'm going to talk about what we need whenever we're performing the ggplot function. So the ggplot function, we can perform it, and you all can follow along with me as I go through this. ggplot parentheses, and this is where we have to add two arguments. The first argument that we have to give ggplot is the data. What do we want it to be plotting? So I'm going to type data equals, and then I'm going to type gapminder because this is the data that I defined earlier that I want to work with. The second argument you have to type is the mapping aesthetic. And again, this is telling ggplot what we want our data to look like, what we want it to map. So we're going to do mapping equals, and then we type AES, that is sort of an abbreviation for aesthetic, parentheses. And in this case, as you can see, we have several different variables. I'm going to designate the X variable as the GD per cap, the title right here, GDP per cap, and then comma, and I'm going to designate my y-axis as life expect. And this is recognizing that I've already made a plot earlier today, but I'm just going to do life expect. And so what do you notice in ggplot? I don't have a plot. And that's because we have to designate layers that we want ggplot to actually create. And actually, I don't even think it did. Let me do Control Enter. Here we go. I didn't hit Control Enter previously. But as you can see, whenever we enter this, we did define the arguments required for ggplot, and it does sort of give us what our axes might look like, but we haven't added any layers to ggplot. So there are a variety of different layers you can add to ggplot. Many. You can research them all online. For today's sake, though, we're going to start by looking at a scatter plot of points. So I'm just going to copy the command I previously gave it, and we add layers to our plot by using the plus sign. And so again, we're going to do a scatter plot of points, and to do this, we can type geom_point. So geom, and you can see some of them already start to come up. There are several, and I'm going to do point. And I'm actually going to leave this You can see the end of my code now. I'm going to leave these parentheses blank. And this is, whenever you leave parentheses blank, it just takes all of your definitions for the mapping aesthetics here and it applies them globally. So that means to all of these points. And so as you can see right here, we have what ours default for ggplot geom points would look like. All of our scatter points are black. It basically chose its own axes label for us. All of these things, though, can be manipulated later if we want, and that's one of the reasons why ggplot is so versatile. So now I'm going to give all of you a little bit of a challenge exercise. So if you have been following up with my code up to here, I want to challenge you, based on using this code as an example, modify it so the figure would show how life expectancy has changed over time. And just to give you all a hint, we do have life expectancy as one of our variables. So I'm going to give you all about 5 minutes to play with this command that I've shown you and see if that's what you can plot. And please ask any questions in the chat box or private message any of the helpers. I'm going to give you all one more minute to wrap up. Okay, so the answer to this question would be to basically modify what we want our x-axis to be. And I'm going to change this in my script to year. It will change the plot that we are seeing, and you can see that now it's organized by year. And this is sort of an example of, again, how smart ggplot can be whenever we're working with tidy data. Notice that we're not having to define what our variables are by using $signs and extracting them from the data matrix. It automatically recognizes what you're talking about when you say year and life expectancy. So that's another reason why tiny data is so helpful to use whenever you're working with ggplot. So now I want to talk about some other things that you can do with ggplot, and one of them is you can manipulate colors. You can do this by going back to maybe a variable that you're using to map, or you can manually change them. For this example, I'm first going to show you how you can color them based on a variable that you have. So I'm going to copy my line of code because I'm just going to work with modifying this and showing you what happens when you modify different things. So I'm again going to be looking at life expectancy over the years, but I'm going to add color equals continent. And remember, continent is a variable in our data, continent. And when we do this, this is the end of my script or my line of code. Sometimes takes a while. And when we do this, you can see like how much more visually appealing this is, and how it's sort of nice how you can see how by color this data is arranged. Now, I'm going to sort of give you all another opportunity to do a quick challenge activity. So taking into account, and if you're following along this previous line of code, if I give you the hint that geom point, again, depicts points as a scatter plot. If geom line gives a line graph, see how the figure might change. And I will give you all, and I'll say, referring to the above code. I'll give you all 1 or 2 minutes just to play with this additional way of adding layers to your data. Again, we're still just using the singular layer, but I'll give you all a couple of minutes. Just let me know when you're done and you can see how that data might change. Yes, so ggplot does automatically make a legend for you, and legends, we won't get a chance to talk about all the ways that you can modify them. You can remove them, you can change the orientation that they're at in your figure, you can make them larger or smaller. It's very easy to find websites online that can help you manipulate these legends. And yeah, like I said, please just say in the chat box whenever you all are done. If you need help, please let me know. I can expand this screen a little bit so you all can see my full line of code. Okay, we're getting All right, I'll give you all about 1 more minute to wrap up. So as I sort of gave the answer a little bit away, we're basically changing geom point to geom line. And as we will see when my R, we can see that it dramatically changes what this figure looks like. If you wanted to take this exact same line of code and maybe differentiate the figure a little bit further, we can also specify how we want it to color it. So we colored it by continent. We can also have it do line graphs by country. So if we add by country, our line graph will look a little bit. And this is something that you can specify with all sorts of different variables if you even wanted to do it by year. These are just some examples. So now let's talk about what happens when we add layers. So similarly to what might happen whenever you add layers in Photoshop or Inkscape, you basically add different overlays to what you previously defined in your figure. And I'll show you a little bit what I mean by that. So for instance, right now in our ggplot, we've defined what we want it to map. Right now, our first layer is adding a line. The first layer you add will always sort of remain at the bottom. And if you add additional layers, they'll be overlaid on top of that. So we previously worked with the geom scatter plot point earlier. Now let's see what happens if we actually decide we want to add both layers. For some, reason, we might want to see individual data points in addition to the line. So I'm going to do geom underscore point and control enter. And as you can see, it's sort of hard to tell right here because our points and our lines are both being colored by continent, since again, we haven't defined if we want the points or the lines to be defined any differently. But you could imagine theoretically that our lines would be the first layer and that our points would be on top of this. Now I can actually specify if I want our points to be a different color. So let's say for whatever reason, I want to color our points black and I want them to stick out against the other lines being a different color. Now you can sort of see that our points are actually on top of our previously defined line graphs. So what I want all of you to do is to try the reverse. See what happens whenever our geom point layers are the first layer. So switch geom line and geom point and play with it if you want. If you want to define maybe a point color other than black, you could even make all of the lines the same color. You can use this as an example, but take a couple minutes to see what happens whenever you add your points as your first layer and your lines as your second layer. I will say, to clarify though, whenever you distinguish something as color equals, you always need to make sure that you put this in quotation marks. So something else to sort of go along with what I was basically talking about defining these different colors. As you saw in the first figure we made before distinguishing our geom points as color equals black, those parentheses had nothing in them. And that meant that everything in our mapping aesthetic specifications applied to those points and those lines. And anything that is defined in our mapping equals aesthetic applies globally or applies to all of the aspects of our layers in our figure. Until you decide to specifically define something within the layers itself, it will not be globally, it will not add globally to everything in your figure. It'll just add to those specific aspects. And I should note that earlier, whenever we were defining our mapping aesthetic, whenever we're defining certain portions of our layers, we don't use mapping aesthetic because all of this has to refer to data in our data frame. And that's why when we do by country, color equals continent, both of these, country and continent, are both variables in our data set. And so if we put color equals blue right here, we would probably get an error. However, whenever we're working with these layers, we can do all sorts of different definitions. We can change the font of things. We can make the colors something that's not actually a part of that data. And if that doesn't make sense, please ask a question about that. All right, I'll give you all 1 more minute. Whenever you're done, just put it in the chat. Okay, so if we want to swap our 2 layer functions around, we can see how that, oops, I cannot use plush. Oh. I think I have to have, let's try that. Here we go. In case you didn't see that, sometimes in the script, if you don't have everything as a single line, it can mess up whenever you press Control Enter. So as you can see right here, I switched the order of my layers, and that made an impact on how they're overlaid. So I just decided to make all of my points pink, and now all of my layers are on top of that. I could also change, if I wanted these lines to be a specific color, I could make them all, let's say, blue. Mapping must be created by, yes. So I take that back. That goes back to where we had our, I can no longer, just try by country online. Actually, no, I think I didn't do color. Need to do color equals blue. And now it should work. So what I made the mistake of is I didn't define color by blue. And so I think it was basically telling me it has to still stay as my color of continent because that's what I did define it as. But now I made all of my lines blue. So there are a lot of different ways you can manipulate that. Something that I personally really like to do with my figures is I like to be able to customize the title of my figures, the axes titles, and sort of how they're arranged, if they're arranged left or right or in the center. So I'm going to show you all how we do that. Whenever, and I'm going to make my lines no longer blue because I don't like how that looks. So whenever we do this, we're going to add an additional layer, and this is going to be our label layer. And so we can take the exact same line of code that we had before this, and we can just add to that. So in order to add a label layer, we're going to do plus because we're adding a layer, and we can do labs, parentheses. This is going to be our layer. And so if I want to change year, I personally want to have the Y in year capitalized. I'm going to do X equals and then year as I want it to be printed. And I will say from experience, you need to make sure that this X is in fact lowercase, R is case sensitive, and it will not work if it's not lowercase. I'm going to do a comma, and I'm going to specify my Y axis as I want it to be life expectancy. And I want to have life capitalized, and I want expectancy to be capitalized. I also want to give a title to this graph. And I am personally going to make, or figure I should say, I'm going to make my figure title, and this is going to be title equals, its title is going to be figure 1. Let's say I'm putting this in a paper. And then I've made, and you can see it's figure 1, life expectancy, year. I personally don't like the fact that figure is to the left. So something else you can do in ggplot is you can add what they call themes to your different labels. And you can do this to your x-axis or your y-axis. I'm going to focus though on my title because to me, life expectancy and year, these look fine. So in order to do this, I'm going to add another layer, even though it's really more so just changing my labels. I'm going to do plus, and I'm going to do theme. And theme comes up with parentheses. I'm going to define this as plot text. Plot title, actually, sorry. Plot title. And you can actually change if you wanted this figure, like it says figure 1 horizontally. If you wanted to flip it 90 degrees and make it say figure 1 vertically, you can do that. I personally just want to change where it is located. And so I'm going to write H just, and I'm going to do equals 0.5. And my interpretation of this is 0.5 is somewhere in the middle. I'm pretty sure that's why it should, let's see, unexpected equals, oh yes, H just. I don't need, let's see, plot title. I forgot to write something else. We need to write element text right here. Plot theme, plot title equals, because I'm talking about my plot title, equals element text, and now I'm gonna have my H just. Element underscore text. And I need to make sure, another thing in R, you want to make sure that you always have the amount of parentheses correct. You see it. All right, so as you can see now, my figure 1 title is right there in the middle, exactly where I want it. And let's say you wanted to change maybe the angle of your axes titles, or you wanted to change, both of them are pretty in the middle right now, but if you wanted them to be oriented more to the left or to the right, you can also change this plot title to axis title, and you can change it that way. But like I said, I personally like where all of these are. So now I'm going to give you a couple minutes. If you haven't followed along with this exercise with me, please just modify the title. I'll write this in here. Modify the title of your figure in addition to the axes titles. Even if you like how they're named after the variables, just go ahead and get a feel for how you can modify the names of these axes titles in ggplot. So I'll give you all about 5 minutes to do this, and I'll make sure that you can see everything that I just did. Okay, it looks like quite a few of you are getting done manipulating the titles and the axes of your figure. If anyone still needs help with that, please feel free to message one of the helpers. We have a few minutes left, so I'm going to teach you what maybe is one of the most important parts of this lesson, how to actually save the figures that you have created. So there's a function in ggplot called ggsave, and this allows you to export the plot. So going back into my script, I'm going to write ggsave parentheses. And a lot of times it will automatically sort of assume that the previous plot that you've made by default is what it's going to save. What you can also do, which I'll go ahead and demonstrate this too, is you can actually give your plot a name. So I'm just going to copy and paste this plot that I have previously made, and I'm going to designate it as plot 1, for instance. And this is how I'm going to store this plot, and I'm just going to paste it into my cannot use post accidentally. Yes, I did accidentally. Let's see. I'm gonna make this, go back and make this all one line again. Hopefully work. Oops. So now it has stored the plot that you had previously seen on my screen. And now whenever I use the ggsave function, I can refer directly to plot 1. So if you haven't done this, what I like to do is within my current working directory, in order to have a place to store things, I like to create another folder, and I'll refer to this folder in the path that I'm about to set in ggsave. So if you want to go into your working directory, I've decided to keep mine as my desktop. I'm making this folder called results. Whether yours is in another folder or if it's in your documents or downloads, feel free to follow along and just create a separate folder for that. Let's see, come back. So I'm going to do, again, ggsave parentheses, and then I'm going to do file name, and this is the name that I'm giving the plot 1 when it will be stored on my local machine. File name equals, and I'm going to type in my directory, which is now results. It's going to assume my current directory plus the results folder when I type this in. And then I am going to give it a name. I'm just going to keep it the same name, plot 1. And I can also designate the type of file I want this to be. It could be a PDF or a PNG. And today I'm just going to write plot1.png. And then I'm going to put a comma, and I'm going to continue to specify things. My plot equals, here I'm defining which one of my plots I want it to save. And this is why I named my plot 1. So plot equals plot 1. And right now, you can also specify the size you want it to be saved as. You could do width equals, and put a number. You can do length equals, put a number. It's not length, it's height equals number. I'm just going to let it save as is because I personally don't care, but you can specify that as you want. You can also specify the quality. So in DPI, dots per inch, I am not going to mess with that right now. It will save, and you can see I did Control Enter and it saved as a 7 by 6 inch image. So I'm going to go back to where that was stored, and I have plot 1, which did not save properly. Let's see. Wonder what happened. Plot 1. Let's see. I'm gonna go back and define. Oh, I accidentally copied something that Dr. Wallace said to me in here. I'm not sure why I did that. Let me go back to my original data and redefine my plot one. Plot one, Control Enter. I'm gonna try see what happens. All right, there we go. I'm not sure why whenever I was copying and pasting my command that something from my messages with Dr. Wallace got copied in there. But as you can see, it is now saved properly because I defined my plot properly now. So if you all want to go ahead and take a couple minutes, save your plots. If you want to play around with the width or the height or the dots per inch, you can also do that. And I'll write that here in my script line. And whenever you all are done practicing saving your figures, write done in the comments box or in the chat box. Yinping, are you still having some troubles?
Oh, I fixed it. Thank you.
Okay, great. In that case, I think it's been roughly 5 minutes. I think a lot of you had quite a bit of success with this. So this is the final portion of my lesson, is saving our figures. So I'm gonna open it up for Q&A, and I think Dr. Wallace would also like to help explain a couple other things.
Okay, thank you, Hallie. Thank you very much. So yeah, I'm gonna do there's a few questions that came up in chat that people wanted to explain, so I'm gonna cover those. I've got to say, I love this module. Those of you who know me know I'm very particular about graphics, and I love being able to make really good, high quality graphics, which ggplot lets me do. So I guess first I'm gonna cover some questions that came up during the chat. So during the lesson. So one was talking about formatting your code. So what Hallie was doing was to make sure everything would work right, was putting all of her code in a single line of code. And that works fine. You can see on my screen we have the ggplot function, and the gonPoint, the gomLine, etc. And if I run this line, you get the plot vaguely like you guys had been making. This works fine because in order to have all these things together, you have to combine them all into a single thing using these plus signs. The problem is that when it's all in one line like this, it's a little hard to read. As you can see, it's very long and it's hard to track down where you want. So there's a trick. You can format this a bit better by letting R know that you're not done yet. And the way you do that is you break the line after the plus sign. So if I go here and I put an enter, then R knows that since there's a plus here, there must be something after that plus. And since there's nothing on this line, it must then be on the next line. And so we'll look at the next line. It's like, oh, okay, here it is. I'll just keep going from there. And so you can keep breaking after all of these plus signs, and that will spread out your different function calls. And actually, by convention, if you look online, most people do it this way, where there's one function per line for these very complex ggplot figures, and that helps spread it out. It is very important that you break after the plus sign, though. If you break beforehand, like this, let's do it this right here. So I'm going to break beforehand. R gets to this point. There's no plus sign, so like, oh, okay, the code is complete. I'm not waiting for anything else. I will run that. And so I will run that, and it runs just fine. But if you notice, these labels and the themes have not taken effect. And if I try to run those, I get an error. And this is one of those weird invalid argument to unary operator that makes no sense, but basically means that, hey, you gave me a plus sign with stuff afterwards, but there's nothing in front of it. That's why the plus sign must be on at the end of a line, not at the beginning of a line. But this is one way you can reformat your code so that it's a little easier to track down what everything is. A good tip here also is that this lets you put comments. I say this line is for renaming the labels. This one is center the title. And that way I can actually have my little comments here telling me what each one of these lines is actually doing, so that it's easier to keep track of, especially if I have to come back during revisions or something and modify stuff. So that was one question of how do you break things across multiple lines. That's how you do. You tell R that there's something more coming by breaking just after these plus signs. You can do the same thing in a function by breaking right after a comma. And you'll notice that RStudio is smart. It recognizes this, and so it indents stuff to say, hey, this is part of the thing above it. That's another way of breaking up long lines of code. So anyway, that's what I was going to show there. There's also a question about manually changing the colors in ggplot. And before I get to that, I actually want to talk about help in general, because ggplot is ridiculously complex. It's very powerful, but that power comes at the price of it being very complex, meaning that there are a lot of knobs you can fiddle, and there's no way you can remember them all. And so more important than remembering what every function call is and what all the arguments and stuff are, you really need to learn, how do I find what I need? And so there's two main ways, which we talked about early in these. First is help. So the help function will tell you the basics about any function you want to know. So I want to know about the theme function. So please help me with theme. And if I run help theme, over here in my help document, this is the help document for the function theme that Hallie used to change the positioning of the title. The positioning of the title. And if you go down here, you'll notice here, there's a lot of things you can change. In fact, every single one of these items is something that you're able to change. And it lists them out, and then it gives a bit more information about them. There's no way you can memorize all this. So it just helps know, okay, if I want to change something, I can look up here and say, okay, this is probably where I want to change some of the formatting. Let's see what it is. So using help functions is important. Even more important is Google, because that's how we do it. So now we're getting down to this question here of changing the color scale, changing which colors are for those continents. Because I've done this before, once or twice. I know it's possible. I couldn't remember what I needed to do for that. And so I want to walk you through what I did in order to get that happening. For that, I just went to Google and I just typed in my question: how do I manually change the colors in ggplot? And you'll come up with a bunch of things about it. I clicked the first one, how to change colors automatically. Look through this. Here we are, changing color by groups, changing colors manually. Okay, I need the scale fill or the scale color manual. Now I'm jumping over this very quickly because these particular answers are not important. What's important is knowing that you use the internet to answer your question, because any question you have about ggplot, hundreds of other people have had before you, and they have asked the question, and the answer is out there somewhere, although sometimes it's not quite this easy to find. But here we go. So looks like it says here that in order to change the colors manually, for a box plot, bar plot, or violin plot filled things, use scale fill manual. For lines and points, use scale color manual. Well, if I go back to our plot here, I've got points and lines, so that's what I want. I want lines, so I'm going to take this. I want the scale color manual. So I'm going to take this plot from up here, just copy it down. And then again, I need to have a plus at the end of this line to say I'm not done yet. I want scale color manual. And then looking back at this help, okay, it's values equals, and then a vector of values. Looks like there are 3 in this case. In our case, there are 1, 2, 3, 4, 5. So values equals our C function, our combined function. Let's just say it's black, red, green, blue, and yellow. So I run this now. Come on. There we go. And you'll see I have notice I have changed the colors now to black, red, green, blue, and yellow. And so that's how you can manually change the colors. But more importantly, that's how you look up how to do things. When you're approaching making plots with ggplot, I highly recommend, instead of saying, okay, this is what I know how to do in ggplot, how can I show my data using that? You start from the other end. You say, this is the plot I want my data to look like. What do I need to do in ggplot to make that happen? And that can sometimes take a while to track down all the information. Like I mentioned, I'm very, very picky about my figures. So I sometimes spend too much time on them, but I have been known to spend 2 or 3 hours just getting a figure just right by tweaking all the little things and looking up all the functions I need to change stuff. But it's really powerful. You can make a lot of things in this. And a lot of the hardest stuff takes place underneath the hood. So you can focus on these little tweaks like the colors and the alignments and stuff that make it what you want it to be, rather than how do I separate all the lines or how do I make a legend. ggplot takes care of most of that for you. So those were the questions that came up in chat. Does anyone else have questions they want to throw out right now to either me or Hallie or anyone else?
So I have a question.
Uh-huh.
So when you're storing another plot, like I run it again and I store it, and it doesn't ask you if you really want to overwrite your first plot that you store of the same name. So is that always going to be the case that you have to be very careful not to sort of copy it over or paste it over? Yeah, saved it over the same name.
Okay, so you're talking about when you're saving to
a plot. Yeah.
Yeah, so we're going to do a simple one here. So let me copy and paste this down. And for the sake of simplicity, I'm going to put this all in one line. So ggplot, year life expectancy plus a scatter plot. Oop. Why is there a plus there? Where am I? Oh, I'm missing a closing parentheses. There we are. So if I run that, this is our early plot. So plot 1 equals that. But then if I go and I say, well, I actually want plot 1 to be not year, let's say it's GDP per capita instead, and run that. So if we look at plot 1, oh, GDP per capita is not found. Just a moment. Probably some typo. Yep. Capitals get you every time. So if you run it and you save the first one, you run it and save the second one, it does not warn you about overwriting it. You just get the second one. That's what you're talking about, right?
Yes.
Yes. Okay, so this is because you're saving it to a variable. And in the same way that you do, like if x equals 5 and then you say x equals 7.
Oh, no, I'm talking about saving it into a file, like, into somewhere else. Yeah.
Oh, if you save it to a file, yes. So
it's just
save plot 1 file equal, or file name equals plot1.ping. Sorry, let's do a JPEG. It will save it. And then if you save it again, you're correct. There is no warning.
There's no way. Yeah.
I do not think there's a way of changing that.
Okay, that's okay. It just have to be careful.
You just have to be careful. But this is a reason for keeping all your code, because if you accidentally overwrite a file, but you have all the code that generated it, you can just redo it again.
That's true.
So this is one reason why generating your graphics using code is so useful, is because if you mess up, if you delete it or whatever, it just takes another running of the code and you've got it back. This is especially useful if you have to change things in revisions or anything like that, where it makes it much easier to update a graphic rather than having to manually go in and tweak everything. So it's like, I'm just looking here in the help file, it's file name, plot, device, path scale, width, height. There does not appear to be an option to do that. There may be one buried deep inside R to warn you if you're going to override an existing file. I don't know what it is offhand. So.
That's all right. Thank you.
Other questions? Okay, thank you all very much. When I send out the notes for this week and a homework assignment, I'll also be sending out a link to some cheat sheets that people find very useful, that essentially they give you the commands and the most common options people use in ggplot. And a lot of people found it really useful to just print this out and have it near their desk so they can refer to it for the most common things they need.
I think I just sent the same thing, Jason.
Excellent. All right. Well,